Okay, direct variation, tables, graphs, and equations. Pretty much the same as slope like we have done and the slope intercept. It's just a little bit different, a little bit easier, honestly. So when we talked about slope intercept, we looked at this equation. Slope equals, or slope intercept form is y equals mx plus b, where the m is the slope and the b is where your line crosses the y-intercept. So with direct variation, it doesn't have a b. There's nothing extra. So that means it's going to always go through the origin, or it's always going to be plus 0. There's not a y-intercept, okay? But the k in y equals kx is the same as the m. So we're still finding slope. We're still looking for the same thing. It's just they give a different formula. But for what you need to know, k and m are the same thing and they equal slope. So what that means is we are going to continue to use the slope formula, y2 minus y1, x2 minus x1. So on the first one, they give us a table, and the sideways tables have confused some people. They've kind of labeled wrong because it looks different. So just be aware that this is your x, and this is another x. So this can be x1, this can be x2. This can be your y1, this can be y2. So when I go to use the slope formula, I'm going to subtract my y, so that would be 6 minus 4.5, and then 10 minus 7.5, okay? Subtracting my y's on top of my x's. So when I do that, when I do 6 minus 4.5, I get 1.5, and then 10 minus 7.5, I get 2.5. I'm going to divide those two, 1.5 divided by 2.5, and I get 0.6. And on my calculator, I get positive, first of all. On my calculator, I'm just seeing 0.6, and it does not continue. That's kind of confusing, but I'm pretty sure it's just 0.6. Number 2, the same thing. Remember, just be aware that these are your x's, these are your y's, so be very careful. You've got x1, x2, y1, and y2. So when you go to subtract, make sure you're keeping your y's together. So 14 minus 10.5 over 2 minus 1.5. So when we subtract those, I've got 14 minus 10.5 on top, which is 3.5, and then 2 minus 1.5 is 0.5 on the bottom. And I'm going to divide those two. So 3.5 divided by 0.5 is 7, which seems weird, but it's not wrong. Same thing here. Be aware of your x's. x1, x2, y1, y2. Be careful when you're subtracting. And these are not going to have y-intercepts, just heads up, because they're direct variations. Same thing on this one, x1, x2, y1, y2. So subtract your y's on top of your x's. And this one was a little weird because of the decimals. But we've got x1, x2, y1, y2. So when I plug those numbers into the formula, x2 minus x1, I've got 0.8 minus 0.4 on top of 4 minus 2. So 0.8 minus 0.4, and I get 0.4. And then 4 minus 2 is 2. So when we divide these, 0.4 divided by 2, I get 0.2, or just 0.2. Same thing here, just be careful. X1, X2, Y1, Y2. On these, the constant or pattern in the equations below, it just wants you to identify the K in each equation. What's the number next to X, basically? So you're not choosing A, B, or C, you're answering A, B, and C. So the constant, or K, for A is 7.25. For B, it's 4. So, and you're gonna keep doing this. And then -7 divided by 8 is -0.875. Same thing here, it wants the constant pattern, it wants K, it wants the number next to X. That's literally all you're doing, is identifying that number. The appropriate volume in millimeters for a volume of fluid ounces is equal to 29.57 times the value of F. So which table represents this? So it's 29.57 times F. So if we look at F, and it's supposed to be 29.57 times F. If I say 29.57 times 29.57, I get 874.38, okay? Not 1. I get a huge number, so that one is not set up correctly. On H, if I multiply 0 times 29.57, I get 0, because anything times 0 is 0. So this one is not going to work. G is set up the same way F is. That will not work. J is the only one that's going to work, because if I multiply 1 times 29.57, I get 29.57. If I multiply 2 by 29.57, I get 59.14. And so on. I could keep going, but that's the reason that one works. Represent these relationships with an equation, y equals mx plus b. So this is our slope-intercept form, where we're going to need a y-intercept and the slope. So on the graphs, the easiest thing to do is find the y-intercept first. And I see it right here, where it crosses the y-axis. So my b is -4 or -4. And I'm going to use that as a point when I go to find my slope. So 0, -4. And I'm also going to use, I think 2 is a point, but I'm not really sure. So I'm going to use this, which is at 3, 5, to find my slope. So if I have 3, 5, 0, 4, I'm going to call this x and y 1, and this x and y 2. So -4 minus 5, and 0 minus 3. So -4 minus 5 is -9, and 0 minus 3 is -3. So -9 divided by -3 gives me a +3. So if we wrote that all out in our slope-intercept form, it would look like y equals 3x minus 4. The next 8 questions, I think, want this scientific notation number written in decimal notation. And the only thing we have to do with this, if you're online, it might help if you get a piece of paper and write this down. So if we have -5.62 is my decimal, I'm going to be moving this decimal according to the exponent. So since it's a negative exponent, that means I'm going to be moving it to the left, and it's a 7. So that means I'm going to move the decimal 7 places, and that includes this number. So when I count, it would look like this. 1, 2, 3, 4, 5, 6, 7. Now I've got a new decimal. And fill those in with zeros. Okay, and there's a negative in front of the whole number. I kind of put a 0 over that. So there should be 1, 2, 3, 4, 5, 6 zeros in front of the 5. So A is out, B is out. Let's count D. 1, 2, 3, 4, 5, 6. That one works. 1, 2, 3, 4, 5, 6, 7. It's going to be D. Same thing on 12, yeah. 2.12, I'm going to move it to the right since it's a positive exponent, and I'm going to move it 12 times, including these two numbers. So I'm going to start counting here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to have 10 zeros because my other two numbers were 1 and 2. So 10 zeros behind the 212. So C is out because they went the wrong way, and D is out because they went the wrong way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to count 10 zeros. So let's check A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Too many zeros. B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same thing here. Looking at your exponent, it's going to go to the left, and it's going to go 9 times because that is what my exponent said. So count how many are, first of all, you can eliminate C and D because they went to the right instead of the left. And then same thing on number 14. Number 15, slope and the y-intercept on a table. If we don't have 0 over here that we can automatically see, we're going to have to find the slope first. So to find the slope first, I am going to pick 2 points. And I'm going to pick these two since they're the smallest and they're positive. So I've got x1, y1, x2, y2. So I've got 24 minus 16 over 5 minus 1. So 24 minus 16 is 8. 5 minus 1 is 4. So 8 divided by 4 is 2. So my slope is 2. And now I need to find the y-intercept. So already they have 1 here on the table. So all I need to do is work my way backwards from there. So luckily, since it's already at 1, I just have to go back 1 time to get to 0. That's my goal, is to get to 0 on the x side of the table. So since I just went back 1 time on the x side, I'm going to go back 1 time on the y side. And my slope was 2, so I'm just going to subtract 2 from that side. So 16 minus 2 is 14. So there's my y-intercept, and there's my slope. Same thing here. We want to find the slope. So I'm going to use these 2 points, x1, y1, x2, y2, 67 minus 12. 13 minus 2, 67 minus 12 is 55. 13 minus 2 is 11. So when we divide those two, we get 5. So that's your slope. Now to get your y-intercept, you've got to work backwards. So I'm going to start with the 2 since that's the lowest, that's the closest to 0, I should say. And I've got to work backwards until I get to 0 over here. So that means I'm subtracting the slope 2 times until I get here. Next, you've got true, false, unit rate, and the letter K both stand for slope. The letter M stands for slope. The formula for slope is y1 minus 2 over x1 minus x2. And the plot to coordinate -6, 2, you would move down 6, then to the right 2. Those are all true, false.